Water with a low pH aggressively eats away at facility infrastructure. Over time, highly acidic water corrodes pipes, leaches heavy metals into the system, and disrupts downstream processes. Correcting that acidity early protects your equipment and keeps your facility compliant. Look at how this liquid stabilizes as the powder dissolves. That powder is soda ash, or sodium carbonate. It is highly effective for water treatment because it performs two jobs at once. It raises pH, and it increases the water's total alkalinity. This creates a stable, buffered system, avoiding the harsh, rapid pH spikes you often get when using caustic soda. Today, we are going to walk through the exact steps to safely handle a 50-pound bag of soda ash. We will mix a trial batch, dial in your target pH, and set up a preventative maintenance routine to keep your feed system running smoothly. Before you start, you need to gather specific equipment. You will need your 50-pound bag of NSF-certified soda ash, a non-aluminum mixing tank, a source of warm water, a calibrated chemical feed pump, an accurate pH tester, and proper personal protective equipment. Taking the time to stage this equipment and understand the chemistry of what you are working with eliminates guesswork. It protects the operator from injury and prevents severe damage to your system's plumbing. Step 1 happens before you ever touch the chemical packaging. Locate your facility's safety data sheet binder and review the documentation for sodium carbonate. This document shows the exact risks we are dealing with. Here in the hazards identification section, you can see that soda ash dust is a severe irritant to the skin, the respiratory tract, and especially the eyes. To handle this powder safely, you must wear long sleeves, chemical splash goggles, an N95 dust mask, and either nitrile or neoprene gloves. Looking at the handling section of this safety data sheet, there is a strict rule. Avoid breathing dust and contact with your eyes, skin, and clothing. You must also physically verify the location of an emergency eye wash station in your immediate work area before proceeding. Respecting these irritant properties and wearing the required protective gear ensures your facility stays compliant with safety regulations, and more importantly, ensures you walk away without a serious personal injury. With our protective gear on, we can start mixing. We begin with a small trial batch because adjusting pH is an iterative process. Dumping a large amount of chemical into the system right away will cause the pH to overshoot the target, wasting expensive materials. This diagram illustrates our starting baseline. We mix 2 pounds of soda ash powder into 5 gallons of water. This ratio creates a conservative 5% concentration that is easy to adjust later. The container you use for this mix matters. Use only tanks made of polyethylene, fiberglass, or stainless steel. Never mix soda ash in aluminum or galvanized steel, as the chemical will react and degrade those metals. Fill your tank with warm water. Warm water helps the powder dissolve much faster, but avoid hot water, which can create unwanted chemical reactions or damage plastic tanks. Notice the pouring technique here. Add the powder to the water in a slow, steady stream. Dumping it too quickly displaces the air in the tank and forces a cloud of irritating dust right into your face. Once the powder is in, you need to stir the solution continuously for 15 to 30 minutes. Rushing this mixing step leaves undissolved powder sitting at the bottom of the tank, which eventually forms solid clumps. Taking the time to ensure a complete clump-free mix guarantees that your chemical feed pump won't clog up. It also means you won't have to drain the tank and throw away a ruined batch. Now, connect your chemical feed pump to the mixing tank and set its initial output capacity to between 50 and 60%. Turn on the main water flow. Let the unit run for a few minutes to allow the treated water to travel through the pipes, then move a few feet downstream from the injection point to collect a representative water sample. Insert your digital meter or testing kit into the sample. This reading gives you your new baseline pH, telling you exactly how the 5% solution is reacting with your specific water chemistry. This flowchart shows the adjustment cycle. If your reading is lower than your target, you have 2 options: increase pump speed to push more volume, or add more soda ash to strengthen the solution. Then test again. If your reading is too high, you go the other direction. Add plain water directly to the mixing tank to dilute the concentration. Let it cycle through and retest. Keep making these incremental adjustments. Once your tester displays your exact target pH, write down the final mixing ratio and the exact pump setting in your facility's logbook. Following this iterative testing cycle and documenting the results gives you a completely stable pH adjustment system. You will know exactly how to refill the tank next week without relying on guesswork or risking sudden spikes in alkalinity. To maintain the stability long term, you have to protect your chemical supply. Soda ash is highly hygroscopic, meaning it constantly pulls moisture out of the air. You must store your 50-pound bags on pallets in a dry, climate-controlled area, or the powder will absorb humidity and turn into a solid, unusable brick. Looking at this maintenance checklist, there are 3 tasks you need to perform regularly: clean your chemical injectors, inspect your delivery tubing for cracks, and physically calibrate your feed pumps. Skipping these basic maintenance steps allows mineral deposits to build up. That leads to clogged lines, highly inaccurate dosing, and eventually total failure of the feed system. When you combine a properly mixed solution with a clean, well-maintained delivery system, the result is smooth, continuous operation. Your logs stay accurate, your infrastructure is protected from acidic water, and you eliminate costly downtime. Now it's time to put this into practice. Before you begin your next mix, go locate your facility's safety data sheet binder and verify that your feed pump is properly calibrated. Taking those steps today ensures your water treatment remains safe, reliable, and hassle-free.